Hey guys, welcome back, I'm Jay. In this episode, we're going to look at Amazon Virtual Private Cloud, VPC. Amazon VPC stands for Virtual Private Cloud. It lets you provision a logically isolated section of the AWS cloud, where you can launch AWS resources in a virtual network. This virtual network resembles a traditional network in a data center, with the benefits of using the scalable infrastructure of AWS. Amazon VPC is a networking layer for Amazon EC2. For example, when you launch an EC2 instance, you will launch it inside a subnet of a VPC. A VPC is a virtual network dedicated to your AWS account. A subnet is a range of IP addresses inside a VPC. You have a default VPC in each region, and a default subnet in each availability zone. A default VPC and subnet are ready for you to use, so that you don't have to create and configure your own VPC and subnet. You can immediately start launching Amazon EC2 instances into your default VPC. A default VPC and subnet are suitable for getting started quickly, and for launching public instances such as a blog or simple website. In addition, you can create non-default VPCs in a region and non-default subnet in an availability zone. So what is the relationship between VPC, subnet, region, and availability zone? VPC and subnet are the logical isolation of networking configuration. Region and availability zone represent geographical separation. Here is what it looks like. We know that inside an AWS region, there are multiple availability zones. They are the geographical separation of AWS resources. When you create an AWS account, you have a default VPC inside each AWS region, and a default subnet inside each availability zone in a region, created by AWS. For example, in the US East 1 Northern Virginia region, you have a default VPC and 6 subnets, which is one subnet for each AZ. You can directly launch EC2, Elastic Load Balancer in the default VPC and subnets, to reach your audience over the internet. Default VPC and subnets have all the networking configuration for you to get started in AWS quickly. In addition, you can create non-default VPCs and subnets, and customize network configuration yourself. Route table contains a set of routes that are used to determine where network traffic from your subnet or gateway is directed. The main route table automatically comes with your VPC. It controls the routing for all subnets that are not explicitly associated with any other route table. You can also create custom route tables. NAT Gateway is a gateway that you attach to your VPC to enable communication between resources in your VPC and the internet. NAT Gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between your VPC and the internet. If a subnet is associated with a route table that has a route to an internet gateway, it's known as a public subnet. If a subnet is associated with a route table that does not have a route to an internet gateway, it's known as a private subnet. Virtual Private Gateway is the VPC side of a VPN connection between your corporate data center and AWS using an AWS site-to-site VPN connection. VPC Endpoints enables private connectivity to services hosted in AWS from within your VPC without using an internet gateway, VPN, or NAT devices. Instances in your VPC do not require public IP addresses to communicate with resources in the service. Traffic between your VPC and the other service does not leave the Amazon network. There are two types of VPC endpoints, interface endpoints and gateway endpoints. For example, if you want to connect EC2 instances in your VPC to Amazon DynamoDB privately, you can use a gateway endpoint. VPC Peering connection is a networking connection between two VPCs that enables you to route traffic between them privately. Instances in either VPC can communicate with each other as if they are within the same network. You can create a VPC peering connection between your own VPCs, or with a VPC in another AWS account, or in a different AWS region. AWS uses the existing infrastructure of a VPC to create a VPC peering connection. It is neither a gateway nor an AWS site-to-site VPN connection, and does not rely on a separate piece of physical hardware. There is no single point of failure for communication or a bandwidth bottleneck. NAT stands for Network Address Translation. NAT Gateway enables instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating a connection with those instances. NAT Gateway enables highly available, managed NAT service for your resources in a private subnet to access the internet. NAT Gateway is only supported for IPv4. Egress-only Internet Gateway is a horizontally scaled, redundant, and highly available VPC component that allows outbound communication over IPv6 from instances in your VPC to the Internet, and prevents the Internet from initiating an IPv6 connection with your instances. Because IPv6 addresses are globally unique. Therefore they are public by default. If you want your instance to be able to access the Internet, but you want to prevent resources on the Internet from initiating communication with your instance, you can use an egress-only Internet Gateway. Route table contains one or more routes that are used to determine where network traffic from your subnet or gateway is directed. Each route in a table specifies a destination and a target. The destination is also called destination sitter, which is the range of IP addresses where you want traffic to go. The target can point to local within the VPC. It can also be Internet Gateway for Internet traffic, Virtual Private Gateway for VPN, or Peering Connection for peered VPC. When you create a VPC, it automatically has a main route table. The main route table controls the routing for all subnets that are not explicitly associated with any other route table. Each subnet in your VPC must be associated with one route table. A subnet can be explicitly associated with a custom route table, or implicitly associated with the main route table. A subnet can only be associated with one route table at a time, but you can associate multiple subnets with the same subnet route table. Every route table contains a local route for communication within the VPC. This route is added by default to all route tables. You cannot modify or delete local routes in a subnet route table or in the main route table. You can optionally associate a route table with an Internet Gateway or a virtual private gateway. When a route table is associated with a gateway, it's referred to as a gateway route table. This enables you to specify routing rules for inbound traffic that enters your VPC through the gateway. In this example, we have a local route that covers any traffic destined for a target within the VPC, and an all-zero route for IPv4 Internet traffic that points to an Internet Gateway. An Internet Gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between your VPC and the Internet. An Internet Gateway serves two purposes: to provide a target in your VPC route tables for Internet routable traffic, and to perform network address translation or NAT for instances that have been assigned public IPv4 addresses. An Internet Gateway supports IPv4 and IPv6 traffic. It does not cause availability risks or bandwidth constraints on your network traffic. There's no additional charge for having an Internet Gateway in your account. To enable access to the Internet for resources in a subnet in a VPC, you must do the following. First, attach an Internet Gateway to your VPC. Next, add a route to your subnet's route table that directs Internet-bound traffic, which is the all-zero address to the target Internet Gateway. You need to ensure that instances in your subnet have a globally unique IP address, such as public IPv4 address, elastic IP address, or IPv6 address. Make sure that your network access control lists and security group rules allow the relevant traffic to flow to and from your instance. Virtual Private Gateway allows to connect your VPC to your own corporate data center, using an IPsec AWS site-to-site VPN connection, making the AWS cloud an extension of your data center. A site-to-site VPN connection consists of two VPN tunnels, between a virtual private gateway on the AWS side, and a customer gateway device located in your data center. To enable a site-to-site VPN connection, you need to attach a virtual private gateway to the VPC. Make sure the remote network includes a customer gateway device. A customer gateway device can be a physical or software appliance, attached to the corporate network. You must configure the route table to enable the site-to-site VPN connection, by adding an all-zero route pointing to the private gateway. So that any traffic from the VPC bound for your network, is routed to the virtual private gateway. AWS only supports IPv4 traffic over a site-to-site VPN, IPv6 is not supported. If a subnet's traffic is routed to an Internet Gateway, the subnet is known as a public subnet. If a subnet doesn't have a route to the Internet Gateway, the subnet is known as a private subnet. If a subnet doesn't have a route to the Internet Gateway, but has its traffic routed to a virtual private gateway for a site-to-site VPN connection, the subnet is known as a VPN-only subnet. The subnet in this example is a VPN-only subnet. A VPC endpoint enables you to privately connect your VPC to supported AWS services and VPC endpoint services, without requiring an Internet Gateway, a NAT device, or a virtual private gateway. There are two types of VPC endpoints: interface endpoints and gateway endpoints. An interface endpoint is an elastic network interface or ENI with a private IP address, from the IP address range of your subnet, that serves as an entry point for traffic destined to a supported service. Interface endpoints are powered by AWS Private Link, a technology that enables you to privately access services by using private IP addresses. AWS Private Link restricts all network traffic between your VPC and services to the Amazon network. A gateway endpoint is a gateway that you specify as a target for a route in your route table for traffic destined to a supported AWS service. Only Amazon S3 and DynamoDB are supported by gateway endpoint. VPC Peering connection is a networking connection between two VPCs that enables you to route traffic between them privately. Instances in either VPC can communicate with each other as if they are within the same network. You can create a VPC peering connection between your own VPCs, or with a VPC in another AWS account, or in a different AWS region, also known as inter-region VPC peering. A VPC peering connection helps you to facilitate the transfer of data. For example, if you have more than one AWS account, you can peer the VPCs across those accounts to create a file sharing network. You can also use a VPC peering connection to allow other VPCs to access resources you have in one of your VPCs. You can establish peering relationships between VPCs across different AWS regions. This allows VPC resources including EC2 instances, RDS databases, and Lambda functions that run in different AWS regions to communicate with each other using private IP addresses, without requiring gateways, VPN connections, or separate network appliances. The traffic remains in the private IP space. All inter-region traffic is encrypted with no single point of failure, or bandwidth bottleneck. Traffic always stays on the global AWS backbone, and never traverses the public internet, which reduces threats, such as common exploits and DDoS attacks. Inter-region VPC peering provides a simple and cost-effective way to share resources between regions or replicate data for geographic redundancy. A VPC peering connection is a one-to-one relationship between two VPCs. You can create multiple VPC peering connections for each VPC that you own, but transitive peering relationships are not supported. You do not have any peering relationship with VPCs that are not directly peered with your VPC. For example, there are two VPC peering connections. VPC A is peered with both VPC B and C. However, there is no direct peering relationship between B and C. You cannot use VPC A as a transit point for peering between B and C. If you want to enable routing of traffic between B and C, you must create a unique VPC peering connection between them. You cannot create a VPC peering connection between VPCs with matching or overlapping IPv4 CIDR blocks. If the VPCs have multiple CIDR blocks, you cannot create a VPC peering connection if any of the CIDR blocks overlap. You can use a NAT gateway to enable instances in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating a connection with those instances. To create a NAT gateway, you must specify the public subnet in which the NAT gateway should reside. You must also specify an elastic IP address to associate with the NAT gateway when you create it. The elastic IP address cannot be changed after you associate it with the NAT gateway. After you've created a NAT gateway, you must update the route table associated with one or more of your private subnets, to point internet-bound traffic to the NAT gateway. This enables instances in your private subnets to communicate with the internet. Each NAT gateway is created in a specific availability zone and implemented with redundancy in that zone. If you have resources in multiple availability zones and they share one NAT gateway, and if the NAT gateway's availability zone is down, resources in the other availability zones lose internet access. To create an availability zone independent architecture, create a NAT gateway in each availability zone, and configure your routing to ensure that resources use the NAT gateway in the same availability zone. The route table of the private subnet sends internet traffic from the instances in the private subnet to the NAT gateway. The NAT gateway sends the traffic to the internet gateway, using the NAT gateway's elastic IP address as the source IP address. You are charged for creating and using a NAT gateway in your account. NAT gateway hourly usage and data processing rates apply. NAT gateways are not supported for IPv6 traffic. You should use an egress-only internet gateway for IPv6 instead. An egress-only internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows outbound communication over IPv6 from instances in your VPC to the internet, and prevents the internet from initiating an IPv6 connection with your instances. IPv6 addresses are globally unique, and are therefore public by default. If you want your instance to be able to access the internet, but you want to prevent resources on the internet from initiating IPv6 connection with your instance, you should use an egress-only internet gateway. To do this, create an egress-only internet gateway in your VPC, and then add a route to your route table that points all IPv6 traffic, which is :/0 address, or a specific range of IPv6 address to the egress-only internet gateway. In this example, your VPC has an IPv6 CIDR block, and a subnet in the VPC has an IPv6 CIDR block. A custom route table is associated with the subnet and points all internet-bound IPv6 traffic to an egress-only internet gateway in the VPC. Egress-only internet gateway is stateful, as it forwards traffic from the instance in the subnet to the internet, and then sends the response back to the instance. A security group acts as a virtual firewall for your instance to control inbound and outbound traffic. When you launch an instance in a VPC, you can assign up to 5 security groups per network interface. Security groups act at the instance level, not the subnet level. A network access control list or ACL is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more subnets. A network ACL has separate inbound and outbound rules, and each rule can either allow or deny traffic. Each subnet in your VPC must be associated with a network ACL. If you don't explicitly associate a subnet with a network ACL, the subnet is automatically associated with the default network ACL. VPC flow logs is a feature that enables you to capture information about the IP traffic going to and from network interfaces in your VPC. Flow logs can help you with a number of tasks, such as diagnosing overly restrictive security group rules, monitoring the traffic that is reaching your instance, determining the direction of the traffic to and from the network interfaces. When AWS creates the default VPC, you get a /16 IPv4 CIDR block to provide up to 65,536 private IPv4 addresses. AWS also creates a default subnet in each availability zone, an internet gateway, a default security group, network access control list or ACL, and DHCP option set. The default size/20 subnet can provide up to 4,096 addresses. The internet gateway connects to your default VPC, so your resources inside the VPC can reach the internet. The default security group and network ACL act as firewalls. Default DHCP option set specifies Amazon provided domain name server for AWS assigned DNS. The default subnet is a public subnet, as the main route table sends the subnet's traffic that is destined for the internet to the internet gateway. EC2 instances that you launch into a default subnet receive a public and private IPv4 address. Without a public IP address, your audience won't be able to reach these instances over the internet. You might have heard of EC2 Classic before. EC2 Classic platform was introduced in the original release of Amazon EC2. However, it is replaced by Amazon VPC. With EC2 Classic, your instances run in a single, flat network that you share with other customers. With Amazon VPC, your instances run in a virtual private cloud logically isolated from other AWS accounts. For all new AWS accounts created after December 2, 2013, AWS doesn't support EC2 Classic, so you must launch your Amazon EC2 instances in a VPC. All new AWS accounts only support Amazon VPC. In this episode, we've learned Amazon Virtual Private Cloud, VPC. VPC lets you provision a logically isolated section of the AWS cloud, where you can launch AWS resources in a virtual network. A VPC is a virtual network dedicated to your AWS account. A subnet is a range of IP addresses inside a VPC. AWS creates a default VPC in each region, and a default subnet in each availability zone. A default VPC and subnet are ready for you to use, so that you don't have to create and configure your own VPC and subnet. In addition, you can create non-default VPCs in a region and non-default subnet in an availability zone. Route table contains a set of routes that are used to determine where network traffic from your subnet or gateway is directed. Internet gateway is a gateway that you attach to your VPC to enable communication between resources in your VPC and the internet. Virtual private gateway is the VPC side of a VPN connection between your corporate data center and AWS using an AWS site-to-site VPN connection. VPC Endpoints enables private connectivity to services hosted in AWS, from within your VPC without using an Internet Gateway, VPN, or NAT devices. There are two types of VPC endpoints, interface endpoints and gateway endpoints. VPC Peering connection is a networking connection between two VPCs that enables you to route traffic between them privately. NAT Gateway enables instances in a private subnet to connect to the Internet using IPv4, but prevent the Internet from initiating an IPv4 connection with those instances. Egress-only Internet Gateway allows outbound communication over IPv6 from instances in your VPC to the Internet, and prevents the Internet from initiating an IPv6 connection with your instances. Security Group acts as a virtual firewall for your instance to control inbound and outbound traffic. Network ACL is an optional layer of security for your VPC, that acts as a firewall for controlling traffic in and out of one or more subnets. VPC Flow Logs is a feature that enables you to capture information about the IP traffic, going to and from network interfaces in your VPC. Okay, that's all for VPC. Thanks for watching and see you in the next episode.
Hope you've enjoyed watching this episode. If you liked the video, please help us and hit the like button. If you want to watch more tutorials, please subscribe to the Cloudemy TV channel. Make sure to turn on the notification and stay tuned. At Cloudemy, we're passionate about cloud and AI technology. Please share your feedback and thoughts in the comments below. Feel free to let us know what topics you'd like to watch. Happy watching and happy learning.